Today we're going to talk about one-sided limits. If I have this piecewise function, look, it says f of x or y is equal to 1. We know that's a horizontal line at 1. But we can only use that where x is less than 1. Here's negative 1. Here's x equals negative 1. If we go to the left, that is our graph, x equals 1. Here is y equals x squared. We know that to be that U-shaped parabola, but moved down 3. So it doesn't surprise us that that 0, 0 point becomes 0, negative 3. Now, if I put in a negative 1 for x, negative 1 squared is 1 minus 3 is negative 2. So we're getting this point here, negative 1, negative 2. Notice the function value of negative 1 is negative 2. We have an open circle or hole here, so the function value is not 1. We're not allowed x in the domain of this red function. So here's the one-sided limit. What's the vocabulary here mean? We're saying take the limit of this piecewise function as x approaches negative 1, but a little bit more. So here is x equals negative 1, and a little bit to the right. We call this the right-hand limit. It's a one-sided limit. As x gets closer and closer and closer to negative 1, hopefully you can see that the y values are headed closer and closer up to negative 2. So y is trending towards negative 2 from the right. The limit of f of x as x heads to negative 1, but a little less. We call this the left-hand limit. Look at the trend in y from the left. Y is positive 1, y is positive 1, y is positive 1. I'm looking at the y-axis to figure out where the y is going as I squeeze in. My x values are squeezing in on negative 1 from the left, and I'm saying, what is y? Well, y is consistently positive 1. I can tell that just looking at the graph. I don't need to make my XY chart. Hopefully, at this point, you can just look at the graph and figure out what the right-hand and left-hand limits are without having to make that XY chart. All right, here's the big question. The limit from the right is negative 2. That's where y is heading. I'm looking at this axis. The limit from the left-hand side is 1. That's where y is heading. The left-hand limit and the right-hand limit do not agree. Whenever that happens, we say that the limit D and E, it does not exist. The right-hand limit does not equal the left-hand limit. The trains on the Y are going into different stations. Now, please don't take the average of negative 2 and 1 and tell me that's the limit. That they both have, the Y trends have to be going towards the same Y for us to use that little trick. But because they're going to different y values, one is going up here, one is going down here, we say the limit does not exist. In this piecewise function, we're not given any kind of equations. We're just told this is the graph of f of x. And we're asked to find the left-hand limit as x squeezes in on negative 2 from the left. Now, we're choosing x values like negative 2.5, negative 2.4, negative 2.3, negative 2.1, negative 2.001. Hopefully, without using any kind of a table, you can see that the y values are trending towards, you guessed it, negative 6. That's from the left. How about from the right? As x approaches negative 2, but a little bit more, so that's negative 2 from the right, where is y trending? Well, y is trending towards negative 2. And now we're asked the two-sided limit. This is a one-sided limit from the left. This is a one-sided limit from the right. Notice the limits are y values. From the left, we're heading to negative 6. From the right, we're heading to negative 2. How about the two-sided limit? As we squeeze in on negative 2 from both sides, where is the y heading? Well, if these two are different numbers, we're automatically going to say does not exist because the limit from the left-hand side does not equal the limit from the right-hand side. Easier questions are like these. What's the function value when x is 0? So they're really asking you, when x is 0, what's y? Well, I've got this point here. It looks like, to me, a 1, a 2, a 3. To my best of my ability, it looks like y is 3. How about the function value when x is -2? What is y? Well, if I go over to -2, I see I have a dark point here and a hole here. So the point is not here, but it's rather there at -6. And f of 1, well, x is 1. What is y? The y value is up there. It's a little higher than 3. Maybe we'll call it, to the best of our ability, 3.2. It is my hope you could look at this piecewise function. Notice they didn't give us the equation, but you could just look at this piecewise function and find the limits. How about as x approaches +3 from the left, the limit of f of x as x approaches +3 from the left? Well, here is +3. As x squeezes in on 3 from the left, look where y is heading. Y is heading towards +1. The limit from the right, as x approaches +3 from the right, well, we're squeezing in on x equals 3 from the right-hand side, and it looks like y is heading also to 1. The left-hand limit is equal to the right-hand limit, so I say the two-sided limit that's written like this will be 1. Let's examine what's happening at -1. As we squeeze in on -1 from the left, look where y is heading. Y is heading up to 4. That's the trend in y. If we squeeze in on -1 from the right, where is y heading? The trend in y is towards 2. Clearly, we can see the left-hand limit does not equal the right-hand limit at x equals -1. So we'd have to say, does not exist. Please don't take the average of 4 and 2 and split the difference. That's not the trend in y. How about the limit of f of x as x approaches -3? Well, this is a two-sided limit, and we're saying, where is y heading? Well, look, y is squeezing in on this point, and I look over here and I see, oh, that's a y value of 2. The left-hand limit does equal the right-hand limit. An interesting bonus here would be, what is the function value at 3? Well, it's not 1. It's up here at 4. So even though the limit of f of x as x approaches 3 is 1, that's the trend in y, we have a hole there, and the point is actually at 4. Not a problem. Even though f of 3 is 4, the limit still is 1, because that's the trend in y.